Imagine having a conversation with an AI that doesn't just sound human, feels like it understands you, adapts its tone, has really deep, specific knowledge about exactly what you're talking about.
Yeah.
We're moving way beyond simple chatbots here. This is about sophisticated voice agents,
Yeah.
handling complex interactions. What actually makes that possible?
It's a fascinating blend, really. A lot of cutting-edge tech working together. And the sources we've been looking at, they give a pretty comprehensive view of the toolkit developers are using right now.
Okay, so that's what we're digging into today. We've got this stack of documents, covers everything from the core tech, customization, adding knowledge, how you integrate it, analyzing performance, the work. Think of this deep dive as pulling back the curtain on how you actually build an AI that can truly talk.
Yeah, our goal here is just to distill the key insights, give you a clear, kind of actionable understanding of this technology, how these really nuanced voice agents actually come together.
Okay, let's unpack this then. What are the foundational pieces? What's working together to make this kind of sophisticated verbal exchange happen? Got to be more than just slapping a voice onto an LLM.
Oh, absolutely. The sources, they really emphasize a few core components that have to work seamlessly. First off, you need really good automatic speech recognition, ASR,
Right.
but specifically fine-tuned ASR. This is super crucial because conversational speech is messy. You've got pauses, interruptions, different accents. The AI needs to transcribe what you say accurately, even with all that noise.
Okay, so getting the words right first, even if it's not perfect audio, then that text goes to the brain.
Exactly. The large language model, the LLM, that's where the transcribed text gets processed, the user's intent is figured out, and the response text is generated. That's the core intelligence, basically, deciding what the agent's going to say.
The intelligence part.
Okay.
And then getting that intelligence spoken back.
So that's the job of text-to-speech, TTS. But again, for these kinds of agents, it needs to be low latency and human-like.
Why low latency specifically?
Well, if there's a noticeable delay or the voice just sounds robotic, it completely breaks the immersion. It doesn't feel like a conversation.
Yeah, okay.
And the sources also highlight something pretty interesting, a custom turn-taking model.
A custom turn-taking model. That sounds subtle, but maybe important. Why is that key?
Because human conversation isn't just perfectly back and forth turns. We interrupt, we might overlap a little bit, we have natural pauses.
Right.
A standard request-response cycle just feels clunky. So this custom model, it manages those dynamics. It knows when to listen, when it's maybe okay to briefly interrupt, how to handle silence. It's what makes the dialogue actually flow naturally, like you're talking to another person, not just waiting for a computer.
Okay, that makes sense. So you've got the accurate ASR input, the powerful LLM processing, that natural low latency PTS output, and this clever turn-taking model managing the actual flow. That composability you mentioned earlier, is that where this comes in, how these pieces fit?
Yes, exactly. The key insight here is that these aren't just bundled together rigidly. The sources really present this as a highly composable toolkit. Developers can pick and choose, configure each of these layers, which is fundamental, really, for building agents for different kinds of needs.
Composable. Yeah. I like that. So you've got this toolkit. Where do you actually start building the agents? Let's say it's personality, its purpose. The sources mentioned a dashboard and prompt engineering.
The dashboard is where you do the configuration, but prompt engineering.
Yeah.
That's really where you define the agent's core identity and behavior. It's all about crafting the system prompt.
Okay, so it's more involved than just telling it, act like a customer service agent then.
Oh, much more. The sources, they break down the system prompt into 6 essential building blocks. Understanding these, it's arguably the most important part of designing how the agent interacts.
6 key building blocks for the system prompt. Okay, lay them out for us.
Okay, first is personality. This defines who the agent is, giving it a name, specific traits, a role.
Like an idea.
Exactly, like the example of Alexis, designed to be friendly and curious for documentation help. Or the pierogi palace, this assistant-friendly, yes, but also efficient, because they need to get through orders quickly. The personality sets the initial expectation for the user.
Got it, the core persona. What's next?
Tone. So how the agent communicates. Is it professional, warm, direct, empathetic? And the sources point out you can even dynamically adjust the tone based on user input.
Oh, interesting.
Like maybe leading with more empathy if the user sounds frustrated or upset. It's not just one static tone.
Right, it can flex.
Okay.
Then environment.
This just sets the stage. Where does the agent operate? Is it in a website widget? Is it taking reservations over the phone? The environment dictates the context, the constraints the agent will likely face.
Defines the scene.
Okay.
4th block.
Goal. What's the agent's main mission? What's it trying to achieve? Resolve an issue, complete a transaction, provide specific info. The prompts define the logic, the pathways to help the agent work toward that goal.
Like its purpose statement.
Yeah. And a key insight here is linking this to analysis later on. You need a clear goal defined here if you want to automatically figure out if the conversation was a success down the line.
Ah, okay. That makes sense. Next up is guardrails. That sounds like setting boundaries.
Critical boundaries, exactly. Guardrails prevent unwanted behavior. Things like staying on topic, avoiding sensitive subjects, maintaining that defined tone, even if the user tries to provoke it. For a voice agent representing a brand, strong guardrails are just essential for safety, for consistency. They stop the agent saying something inappropriate or totally off the wall, which is a much bigger risk in a free-flowing voice chat than in text.
Yeah, you want to prevent those dreaded AI mishaps, especially live on voice. Okay, and finally, tools.
Tools give the agent abilities beyond just talking. This is where you define how it can access external information, like a knowledge base we'll probably talk about, or perform actions. Things like looking up order details or triggering a redirect for the user. It's the agent's interface with other systems.
Okay, so personality, tone, environment, goal, guardrails, and tools. That's a really structured way to engineer the core behavior. It's not just one instruction, it's layers.
Exactly. And getting those layers right, especially how the goal and guardrails play together, that's where the real design challenge often lies.
Okay, so we've defined the agent's brain with these prompts. Now let's talk about its voice. The sources make it really clear that the sound of the voice itself hugely impacts how users perceive it.
It absolutely does, yeah. The sources talk about having a library of voices and even suggest use cases. They mention voices like Jessica Ann Bogart for maybe more empathetic roles or Stuart for technical help. Choosing the right voice immediately sets a certain vibe.
And you're not just stuck with the default sound, you can tweak it.
No, definitely not. You have significant control through voice settings. The sources detail parameters like stability. This influences how consistent versus, say, emotionally dynamic the voice sounds. Lower stability means more variation, maybe more expressive. Higher stability keeps it very steady, very measured.
Stability. Interesting. So you can make it sound more animated or more flat.
Kind of, yeah. More expressive or more consistent is how they put it. Then there's similarity.
Similarity. What's that do?
It affects clarity and, again, consistency, balancing, making the voice sound clear with avoiding maybe potential distortions if you push the setting too far, finding that sweet spot for naturalness.
Okay. And speed. I've definitely hung up on systems that talk painfully slowly.
Yeah.
Or way too fast.
Totally. You can adjust the pace, looks like from 0.7x up to 1.2x speed, with 1.0x being the default human speed. And the sources note the most natural range is usually somewhere between 0.9x and 1.1x. An interesting insight they mention is adjusting speed based on the content. Maybe slow down for complex instructions, speed up a touch for simple confirmations.
That level of control seems important. What about more advanced stuff? Can the agent use different voices within the same conversation?
Yeah, that's multi-voice support. The sources show how you can use simple, like XML style tags, something like voice name teacher or voice name student, right inside the agent's response text. That makes it switch voices.
Oh, cool. What would you use that for?
Well, things like multi-character dialogue, maybe storytelling, or even just clearly marking different parts of an interaction, like reading a legal disclaimer versus the main conversation.
So it can literally perform different roles vocally.
Nice. And what about those tricky words? Company names, technical jargon, things that are easy to mispronounce.
Ah, that's handled by the pronunciation dictionary. You can add specific words and then define exactly how they should be pronounced using phonetic notation, like IPA. That ensures the agent says them correctly every single time. Crucial for brand consistency, avoiding awkward mistakes.
Yeah, nobody wants their company name butchered by their own AI assistant. Okay, and finally, language-specific voices. Key for multilingual agents. So instead of trying to make one voice speak, say, English and Spanish with maybe mixed results, you assign specific voices that are optimized for each language. That, plus built-in language detection, helps make sure the agent sounds natural and native, whichever language the user is speaking.
It really sounds like you can sculpt the whole auditory experience then, not just the words, but how it sounds, making it feel authentic for whatever role it has.
Precisely. Yeah, the voice is often that first impression, and these tools give you really granular control over it.
Okay, we've got the brain defined with prompts, the voice is dialed in, but what if the agent needs info that's not in his general training? Your company's specific return policy, or details from a product catalog.
Right, that's where knowledge bases come in. These are basically curated repositories of domain-specific information that you feed to the agent.
So like uploading internal documents or FAQs, that kind of thing.
Exactly. The sources list examples like product manuals, HR docs, tech guides, customer support, FAQs. You can populate a knowledge base by uploading files, looks like PDFs, Word docs, HTML, even EPBs are supported. Or importing from URLs or just adding text via the dashboard or an API.
Okay.
They do mention some practical limits, like around 21 millib per file currently, something like that.
But what if your documentation library is huge?
Yeah.
Like gigabytes of stuff. Does the LLM try to read everything every single time someone asks a question? That sounds impossible, or at least really inefficient.
That's the exact problem solved by Retrieval-Augmented Generation, or ROG. This is arguably one of the most significant pieces for giving LLMs deep, specific knowledge without totally overwhelming them.
R8. Okay, how does that work? In simple terms.
LLMs have this limited context window, right? They can only process so much text at once. RI gets around this by smartly searching your large knowledge base first. User asks the question. The system finds the most relevant bits of info in your documents, and then it only passes those specific relevant chunks of text to the LLM, along with the conversation history, of course. The LLM then generates the response using that targeted information.
Okay, so it's not trying to hold the entire library in memory. It's doing a quick lookup for the relevant facts for this specific question. What are the big advantages of doing it that way?
The sources highlight several really critical benefits. One, you can access vastly larger knowledge bases than you could ever fit in a prompt or context window. Two, responses become more accurate because they're grounded in facts from your specific documents, which dramatically reduces hallucinations.
That's huge. The AI making stuff up is a major problem.
Totally. And it also lets you scale knowledge across lots of agents pretty efficiently. You just update the central knowledge base.
Okay, reducing hallucinations is a big one for trust. Did the sources mention any trade-offs with ROG? Does it add delay?
Yeah, there's a small added step for that retrieval. It takes about 500 milliseconds, give or take, because the system has to search the knowledge base before it can generate the response.
That's okay.
But the benefit is you can work with much larger individual knowledge items, up to 10 millib per document with RD turned on, apparently, compared to much smaller limits without it. The sources also touch on configuration details like embedding models and chunk size, which affect that balance between latency and accuracy.
So Argy is basically the engine that turns a general LLM into a specialist using your own data. That feels absolutely critical for most real-world uses.
It absolutely is. It's how you move from general AI knowledge to specialized, reliable knowledge for your specific needs.
Okay, so once you've built this intelligent, knowledgeable agent, how do you actually deploy it? How do users interact with it?
The main way discussed in the sources is the widget. This is basically an embeddable component that you put on a website.
Yeah.
And it supports both text chat and the voice interaction we've been focusing on, so it's multimodal.
So that little chat bubble you often see on websites, that could be the front door for one of these sophisticated voice agents.
Exactly. And the sources go into quite a bit of detail on widget customization. You can match it to your brand colors, shapes, button text. You can add things like terms and conditions using Markdown, enable language selection if your agent speaks multiple languages. There's even an option for a shareable landing page if you don't want to embed it directly on your site.
Okay, so the widget gets the agent onto the user's screen. But how do you make the agent aware of the specific user it's talking to? Like knowing my name or maybe my account tier or something.
Personalization. Super important for making interactions feel relevant. The sources describe two main ways to pass user-specific info to the agent, either at the start or during a conversation.
Yeah, what are those?
The first one, which they seem to recommend for maintainability, is using dynamic variables. You define placeholders in your prompts or messages, like username or maybe account type.
Got it.
Then, when you initiate the conversation for a specific user, you pass in the actual values for those variables, and the agent just automatically uses them.
So the agent's greeting could dynamically become, "Hello, Sarah," instead of just, "Hello."
Exactly. The other method is overrides. This is a bit more heavy-handed. You can completely replace default settings just for one specific conversation, provide an entirely different system prompt or a different first message, or even use a different voice ID just for that one user session.
Overrides sound powerful, but maybe harder to manage if you're doing it a lot.
They offer maximum flexibility, yeah, but dynamic variables are generally recommended for scalability and easier management day to day. The key thing is how this data gets to the agent. Usually it's passed when the call starts, maybe via an API call from your backend or front end. The sources mention a webhook example with Twilio integration.
So you can link your existing user data or session info to personalize the AI interaction. What about giving the agent the power to trigger actions on the user side through that widget?
Right, that's handled by client tools. These let the agent, through the widget, trigger actions in the user's browser or application.
Like what kind of actions?
Think about an agent finishing up a support issue and saying, okay, I'll redirect you to the help article now, and then boom, the browser actually a redirect.
Ah, okay. That adds a lot of workflow potential. Can the user's side, like the website, send information back to the agent after one of these tools runs?
Yes, that's a key capability. The sources mention a wait for response option for these client tools. If you enable that, the agent pauses, the client-side action happens, maybe it retrieves some data from local storage or something, and then the information gathered is sent back to the agent. It gets added to the conversation context so the agent can use it in its next response.
Interesting.
The example given was retrieving specific customer details on the client side and passing them back for the agent to use.
That creates a really powerful loop then. The agent can trigger UI actions, and the UI can feed specific real-time data back to the agent. Opens up much more complex workflows.
Yeah, it bridges the gap between the AI conversation and the actual user interface or the underlying application logic.
Okay, we've covered what the agent is, what it knows, how it sounds, and how it connects with user data and interfaces. Now let's talk about the feel of the live voice conversation, the rhythm, the flow. The sources touch on fine-tuning that.
Right, controlling things like silences and interruptions. So timeouts determine how long the agent waits if the user goes silent before it prompts them again. Are you still there?
Yeah.
Kind of thing.
What's the range there? Does it make a big difference?
The configurable range is apparently 1 to 30 seconds, and the sources highlight the trade-off. A shorter timeout, say 5-10 seconds, makes the agent feel really responsive, keeps things moving, might be good for quick transactions.
Right.
But a longer timeout, maybe 10-30 seconds, gives the user more space to think or maybe formulate a complex answer. Could be better for technical support or detailed questions. It's about matching that pause duration to how users likely behave in your specific scenario.
That's actually a surprisingly important detail for how natural it feels. And interruptions.
This is basically a toggle switch. Can the user talk over the agent while it's speaking? You can enable it or disable it.
When would you ever disable interruptions? Doesn't that feel unnatural for a conversation?
It does, for pure naturalness, yeah. But the sources point out specific cases where making sure the entire message gets delivered is absolutely critical. Think about reading out legal disclaimers or safety instructions or confirming crucial order details, places where you cannot afford the user interrupting and potentially missing vital info.
Oh, okay. That makes sense. So you might disable it just for that specific critical utterance.
Exactly. You can control the pacing and prevent being talked over when necessary. These settings seem small, but yeah, they have a huge impact on the user's perception of the conversation's fluidity.
They really refine the experience, moving it from just talking at an AI to having a well-managed conversation with it. So once your agent is live, it's having potentially thousands of conversations. How do you know if it's actually doing a good job? How do you spot where it needs improvement?
This is where the analysis and improvement tools become absolutely essential. The sources really highlight the importance of monitoring performance, mostly through the dashboard.
What kind of data are you seeing there? Basic usage stats?
Yeah, standard stuff like the number of calls, average duration, cost. You can see language usage, monitor active calls in real time. But beyond those basics, there are more powerful analytical features.
Like what? How do you know if a call was actually successful?
That's success evaluation. This is a really key insight from the sources. You don't just guess. You define custom criteria using prompts that the system then automatically uses to evaluate each conversation transcript against.
Custom criteria. So you tell it what success looks like.
Exactly. Based on your criteria, it tags each conversation as success, failure, or maybe unknown, and it even provides a rationale for why it made that judgment.
So you could tell it, for example, a successful call is one where the user's main query was answered and they didn't ask to speak to a human agent.
Precisely that. Or, thinking back to the Pierogi Palace example, success might be defined as the agent confirmed all necessary order details, the items, the quantity, delivery address, and the total price. It gives you a measurable, objective way to score how well the agent is performing at scale.
That's powerful. Ties right back to the goal we defined earlier. What about pulling specific bits of info out of the conversations?
That's data collection. The feature lets you automatically extract structured information from the transcripts. Things like contact details, specific order items, user preferences, whatever you need. You define what you want to extract using a detailed prompt description to guide the process.
So sticking with the pierogi example, you could automatically pull out a list of pierogi types and quantities ordered from every single conversation transcript.
Exactly like that. You define the schema, what data points you want, and the system goes through the unstructured text and pulls them out for you.
Okay, so you're getting usage metrics, automated success failure scoring based on your own rules, and structured data extracted from the actual conversations. What's the big picture value of having all these analysis tools?
The key insight really is that these tools enable a vital cycle of continuous improvement. You're not just deploying an agent and crossing your fingers.
Right.
You use these metrics, these evaluations, this extracted data to pinpoint exactly where the agent might be struggling. Then you can refine its prompts, update the knowledge base, maybe tweak the voice settings or timeouts, and then you measure the impact of those changes on the next set of conversations. It's ongoing refinement, driven by real-world data.
That makes total sense. An AI agent, especially doing complex stuff, needs that feedback loop to actually get better over time. Okay, let's peek a bit further under the hood. The sources mention choices for the LLM itself.
They do, yeah. The platform integrates with various LLM providers, mentions Google, OpenAI, Anthropic, and allows for custom models too.
And is that choice of LLM, does it matter much?
Yes, the sources indicate it definitely impacts several factors. The complexity of tasks the agent can handle, the processing latency, the size of the LLM's context window, and importantly, the cost. Different models have different strength and different price points per token.
Okay, cost. How is that structured usually?
Pricing is typically based on tokens processed. That includes the input, your speech transcribed, the output, the agent's response text, and any internal cache usage. The sources also show an average cost per minute, which might be more intuitive for voice. And they note that LLM costs themselves will start being passed through directly, so the model you choose will directly hit your running costs.
Tokens. Makes sense. What about those silent periods in a voice chat? Am I paying full price if the user's just thinking for a bit or looking something up?
Ah, that's a good detail from the sources. Apparently, after about 10 seconds of silence, the system optimizes things, and those extended silent periods are charged at a significantly reduced rate, only 5% of the usual per-minute cost.
Oh, wow. Okay.
That's a pretty important optimization for voice calls, which naturally have pauses.
That's a relief. Okay, finally, security. If you're putting these agents out there, especially if they handle sensitive customer interactions, how do you lock them down? Secure access.
Yeah, security is paramount. The sources detail a couple of primary methods for authenticating connections and stopping unauthorized use.
Like what?
One method is using signed URLs. So instead of exposing your main API keys, you generate a temporary, unique URL for each specific conversation session. This URL contains authentication info and it's time-limited. Provides a secure way to initiate that connection.
So like a unique temporary key for each interaction.
Essentially, yes. The other main method is allow lists. This basically restricts which domains or host names are even allowed to connect to your agent's endpoint in the first place.
So you explicitly list, say, the specific websites or applications that are authorized to use your agent.
Correct. And the strongest approach, as recommended by the sources, is actually combining both methods, requiring a signed URL and only allowing connection requests for those signed URLs if they come from specific allow-listed domains.
Got it. Layers of security to make sure only legitimate apps and users can talk to your agent.
Exactly. Protecting both the agent infrastructure and, any data that might be passing through it.
Wow. Okay. We've really gone from the fundamental building blocks all the way through to deployment, analysis, and security. We started with that core tech, the ASR, LLMs, TTS, that clever turn-taking model, and how it forms this composable toolkit.
Yeah, then we explored how to define the agent's personality and purpose using those 6 key building blocks for prompt engineering. Personality, tone, environment, goal, guardrails, and tools. And understanding how they interplay.
Then how to give it a voice.
Yeah.
Actually customizing the sound with settings like stability, similarity, speed, and adding those advanced features like multi-voice support and pronunciation dictionaries.
We saw how knowledge bases, especially when powered by a RAG, let agents tap into huge amounts of specific domain expert info without getting overwhelmed, really tackling that hallucination problem for custom data.
How the customizable widget acts as the interface, and how personalization using dynamic variables or overrides, plus those client tools, allow for really deep integration into existing workflows and user experiences.
How fine-tuning the conversational flow itself, with things like timeouts and interruptions, really impacts the perceived naturalness of the whole dialogue.
And critically, how those analysis tools, success evaluation, data collection provide the crucial, actionable insights you need for continuous improvement, making the agent genuinely smarter over time based on real interactions.
Plus, yeah, understanding the LLM choices, the token-based pricing with that neat silent period optimization, and how to secure access using signed URL and allow lists.
It's really clear from this deep dive. Building these isn't just about plugging in an LLM. It's a pretty sophisticated design process involving all these configurable layers. So, thinking about the level of customization that's possible here across the voice, the personality, the knowledge, the integration points, that whole analytical feedback loop, this toolkit really allows for incredibly tailored and capable AI voice agent. Considering all of that power and flexibility, where do you think we'll start encountering these really sophisticated AI agents most frequently in our daily lives? And how might that fundamentally change some of the interactions we currently have, maybe with businesses or services?